So for today's project, I'm going to be talking about how we could theoretically send a probe outside of our solar system. So after watching the video, we learned kind of a lot about Kepler's laws and how that might interact with Newton's laws and ideas on gravity. So if we're going to be sending a probe into space, obviously we want it to be able to get out of our solar system, because if it gets stuck inside, you're going to get that elliptical orbit around the sun, and that wouldn't really do us any good. Something that I thought was important was Kepler's third law that he mentioned in his lecture. So it talked about, how fast something would be moving. And then more importantly on this slide, he showed an equation that showed how these were able to be derived from Newton's law of gravity. And Newton's law of gravity is really important because in order to get out of the solar system, basically we need to be able to travel far enough to overcome this gravity. So we know that our gravity is pretty strong in relation to obviously not having gravity outside. And so how we need to combat this is very important by making sure that the speed of the launch can overcome and travel a distance far enough in order to get out of or overcome the gravity. So one way to do this, really the main way I was thinking about, is to really ensure that our probe is traveling the right speed. So a probe could be launched by like a rocket or on a space shuttle, and this kind of goes into Newton's laws of motion that I'm going to be talking about a little bit. So if you have one object attached to another, you're going to get the inertia from that object. So it's like a person traveling within a car. So you're still traveling that speed, even though the car is doing the work to move. So that's a way that the probe could be launched, is kind of like taking a piggyback ride on something else to ensure that the speed it has will be coming from that object. Something else to talk about is the event that, let's say, we didn't have enough speed and we got stuck within our solar system, right? So then you could think of Newton's third law, where if something ran into that probe within the solar system, you could have that probe, the whole track of it could be messed up. So it's just a lot more risky if it's obviously orbiting us. We have a lot of things orbiting around the sun. We have many different planets. There's debris in space. There's satellites out there. So if it does get stuck in our solar system, by not overcoming that gravity, it could be a little bit dangerous to us. It might get struck by something, could even fall back, what they call fall back to Earth. So that wouldn't be good. So we really want to make sure that we look at Newton's law of gravity, and within our equation find a way to get the probe far enough from us that it isn't influenced by gravity. So yeah, that's what I found important in today's video.